Right. On Friday, I showed you how to multiply radicals. We didn't look at dividing radicals at all. So let's start with page 201. The same rule goes for dividing as it does for multiplication. If you have a root, you can divide within a root. If you have a root, you can multiply within a root. But you can't multiply a whole number by a root and get something different, okay? Because they're entirely different. So in this case, I have 15 square root 15xy over square root 5x. Just simply do the math on it. Okay, 15 divided by 5, 3. X divided by x is 1. So it works out to square root 3y. We do not get rid of that square root value. Once you're working within the roots, you got to stay within the roots. Okay? Now, if there was a number on the outside, for example, like this, okay, 4 over 2, I can put that here. I can divide those and make that 2 square root 3y. Okay? That's not the important part. The important part is what we say is rationalizing denominators. So one of the things, there's two things that you always want to avoid. Number one is a 0 on the bottom of a fraction. Okay, that gives you an undefined value. You can't have that. The second thing you want to avoid is a square root value on the bottom of a fraction. So we need to rationalize it, which means that we get rid of that square root on the bottom. So for example, I have 8 square root 5 over 2 square root 3. I don't want to have a square root on the bottom of a fraction. I want to rationalize it, which means taking an irrational value and creating a rational value. That's what rationalizing means. So in this case, the only way I can do that is by multiplying by 1. So I want to get rid of the square root 3. If I multiply square root 3 by square root 3, I get square root 9, which is just 3. That becomes a rational number. But whatever I do to the bottom, I also have to do to the top. All right? So 8 root 5 times root 3. 8 square root 15. And on the bottom, I have root 3 times root 3, which is square root 9. Square root of 9 is 3. 3 times 2 is 6. And then I'll reduce that to that. There's my simplified answer. You have to rationalize all fractions. You cannot have a square root on the bottom of it. And the only way to rationalize is to multiply the square root by itself. Okay? And again, this is not calculator work. This is all work that needs to be done in your head or with a pen and paper.
I don't get how you do the square root 3 over square root 3.
What is square root 3 divided by square root 3? What is it? 1. So I'm not really doing anything to change this, am I? So whatever I have to multiply this by, to change that to a rational number, I have to multiply by itself. But whatever I do, I can't just multiply it by itself. I have to do the top as well so that I'm not changing the value. So if you were to actually, I wouldn't do this, I don't want you to do this, but if you were to take that and divide it on and use a calculator to solve it, it would equal exactly that. All I'm doing is changing it so that I don't have a square root on the bottom of the fraction. It's called rationalizing. So if I have this times top and the bottom by root 3 over root 3, which is just 1. So that's 4 root 3 over 3. I just rationalized it. All I'm doing is changing the form of it so that I don't have this on the bottom.
So then you just, on top, when you got the 6, you just do the 2 times the square root 3.
What's square root 3 times square root 3? What's 3 times 3, Lexi?
Oh, 9.
So what's the square root of 9?
Oh, okay.
3 times 2? 6. Okay? This is the easy one. The hard one is the next one I'm going to do. So this is the one that causes grief for most. All right. Now, I can't just multiply this by one value in order to get the square roots. I'm going to multiply this by what we call the conjugate. It's the additive inverse of it. Now, here's how you think of this. What is a squared subtract b squared? What is it? If I were asking you to factor a squared subtract b squared, what is it? Thank you. Difference of squares, correct? A squared subtract b squared. We agree? A minus b, a plus b. This works the exact same way. Because what's happening is I'm going to go the opposite direction. Instead of going, so now I've got this. So when I have a minus b times a plus b, what does that give me? A times a squared, minus b squared. So what have I done? By multiplying this guy by its additive inverse, a plus b, I've created a squared subtract b squared. Now when I square a square root, what happens? It becomes a rational number. So what I'm going to do then is multiply this guy by, I'm going to do it by everything on the bottom. This. So I'm multiplying it by its additive inverse. 5 root 3 plus root 2. Because what is that going to give me? When I take a subtract b times a plus b, it's going to give me a squared subtract b squared, which then gets rid of my square roots. So in this case, I have 7 times that is 35 root 3 plus 7 root 2. Multiply that across the top. This guy, actually leave your pencil down so you can follow, otherwise you ask questions. This guy now becomes that squared, subtract that squared. Well, what's 5 root 3 squared? What's 5 squared? 25. What's root 3 squared? 3. What's 25 times 3? 75. Subtract. What's root 2 times root 2? What is it? 2. 35 root 3 plus 7 root 2. Because they aren't the same, I can't do anything with them, and I can't reduce anything. There it is as a rationalized value. Bless you. So you have to multiply by your additive inverse, we call it the conjugate, in order to rationalize this value. Okay? That's all there is. There's multiplying and dividing. That's all there is in 5.2. You should have got a bit of a start on that. If you're not, then you're not doing anything after work, after school, which you may have to. I'm going to do another example for this guy. Like I said, these ones are a little bit harder. Oops. Okay. I need to rationalize this. So what am I going to multiply by in the top and the bottom in order to rationalize this? Square root of 6 what? Subtract 2. 6. Root 6 minus 2. Root 6 minus 2. Okay. When I multiply these two together, 3 times 1 is 3. Root 5 times root 6 is root 30. 3 root 5 times minus 2 is minus 6 root 5. Nope, you can't. You can't multiply a value that's a rational number by an irrational number. So I'm taking this times 2, which is 6. The root 5 has to stay as is. You can only multiply a root by a root. Okay, and then on the bottom, what am I left with? Root 6 squared, which is? Square root of 36, which is 6, right? And then subtract 4. 3 root 30 minus 6 root 5 over 2. So the first thing that you have to do is you have to be able to multiply by the additive inverse. You have to identify it and multiply by it. Then the second thing you have to do is multiply correctly.
Why would you multiply by negative 6 squared, negative 2?
Okay, say that one more time, please.
Why would you multiply by negative 6 squared, negative 2?
Negative 6 squared?
Yeah.
Subtract 2?
Yeah.
Like right here?
Yeah.
Negative 6 squared?
Mhm.
Because again, I can't multiply 6 by a root. Right? I have to multiply a root by a root. Okay? So negative 6 squared would give me negative 36, agreed? But then when I times that by root 6, that gives me negative 36 root 6. You follow what I'm saying? Okay, so I have to multiply it by exactly what is written here. That's the easiest way to think of it. And then you won't make errors. Okay? Do another one here. Okay? So write that down somewhere on a piece, on your book or a piece of paper. Write it down. Multiply it out. See what we get. What do I gotta multiply the top and bottom by? Okay. Alright. How many of you were able to do the top part? You did. Somebody else? On? You did the top? Okay, anybody else? What did the top ask you to do? Multiply a binomial by a binomial. What do you do? Eventually, yeah. But that's FOIL. Binomial by binomial. So let's multiply it. First, 4 root 2 times root 3 is what? 4 root 6. Outside, 4 root 2 times root 5. 4 root 10. Inside, minus 1 times root 3. Last, minus 1 times root 5. All that is over root 3 times root 3, which is 3. Root 5 times root 5. 5. 3 subtract 5. There's your answer. It's as simplified as it gets right there.
So how come the top part was so long compared to the other ones? Just because extra.
Because you're taking a binomial times a binomial, which is normally when we do that, your middle terms have the same value, so then you add them together. But because we're using different roots, I have no like terms to collect. You understand what I'm saying? So if I have this, just for example, right? If I have this, I have x squared plus 3x plus 5x plus 15, right? But I have two like terms there. So I have to collect them. So I get x squared plus 8x plus 15, right? I'm doing the same thing here. The only difference is these two don't have the same values, same terms, because the roots are different. So that's why it's longer.
So if that one didn't have the minus one, then you would have done
Yeah.
the other time. So
Yeah. So I put that in there intentionally.
So when you're collecting, like, shouldn't it be 4 root 16?
I have 4 apples and I have 4 bananas. Can I add those together?
No.
So then how come you're doing it there? Remember, you got to treat the roots the same way as you do variables. If you don't have all A's or all B's or all X's, you can't add them together. They're different. So square root 10 and square root 6 are different. You can't add them together. You treat them the same way you do variables.
So I can't do anything like that.
There's your answer, right there. Okay? That's the most complicated one you're going to get. Alright? I'm going to give you the rest of today to finish to the end of 5.2. You will have it done for tomorrow. Okay? And like I said before, I'm not expecting you to do every single question in 5.2. I'm expecting you to do enough questions in 5.2 that you know how to do it. The problems and things I'm not so worried about. You will not do radicals past this class. You don't do it in grade 12. So we just need to get it done and do it the way they want you to for grade 11. So I want this wrapped up this week. You're going to test by Friday on this. So that means 5.3 tomorrow, review Thursday, test Friday.
is it next Friday? It's next Friday.
Okay? So that's it. Alright? I'm going to work with the 12s now, and then I'll come back if you guys have questions on the 5.1.